A bacteria population starts with 400 bacteria and grows at a rate of R of t, which is equal to 450.268 times e to the power of 1.12567 t bacteria per hour. Question states, how many bacteria will there be after 3 hours? So this is, if we take a look at the problem here, we know that R of t is going to be an exponential function. And so that formula is a times e to the power of b times t. So what does a equal in our problem? Well, we know that a is given to be the initial population, which is 450.268. Okay, and the value of b is equal to 1.12567. And we also know that n of t is going to be the population after t hours. Okay? So, now we know that since R of t is equal to the derivative of that population after t hours. So what does this look like? Well, we want to integrate because we want to find after 3 hours going from 0 to 3 of R of t dt. Well, what does that equal? Well, that's going to equal n of 3 minus n of 0, which is the total change in population after 3 hours. Now, since we start with 400 bacteria, then we would say the following for the population. We can see here that n of 3 is going to equal the following. We have the initial population, so we start with the 400 bacteria, plus we're going to integrate the function from 0 to 3, R of t dt. So what does that equal? So let's go ahead and change this. So now we know that this is going to be 400 plus, well, what did we say R of t dt is? Well, that is this function here, a e to the bt. So that's a times e to the exponent of b times t. And so then what is the antiderivative of that? Well, if we take out the constant, which is a, and then we're going from 0 to 3, we have e to the bt dt. And so now we need to find the antiderivative of that. So what is the antiderivative of this? So let's take the antiderivative of that. So what would be the antiderivative? We would know that u is going to equal bt and then du is going to equal b times dt. And then we're going to divide both sides by b. So therefore we'd have 1 over b du, which is equal to dt. Okay, so now let's go ahead to step 4. So we know that our original integral is going to go from 0 to 3. And that's a, and that's e bt du. So this is going to be a from 0 to 3. Oops. Well, let's go ahead and first not write the lower bounds, upper bounds yet. So we have EU times 1 over b du. And so we know that the upper bound is going to be u, which is equal to bt. So if we substitute 3 in for t, then the upper bound is going to be 3b. And then the lower bound, u, is going to equal bt. So that's going to be 0 times b. So we end up getting a going from 0 to 3b. We're going to factor out the 1 over b, which is the same thing as a over b, and that's EU du. Okay, now let's take the antiderivative of that, and we get a over b times e to the power of u going from 0 to 3b. So this is equal to a over b times e to the 3b minus e to the 0. So now we can rewrite that over here as to what we get for our results. So we have 400 plus a over b times e to the 3b minus e to the 0, which is 1. And now let's go ahead and substitute what we know a and b is from the beginning of the problem. We know that a is equal to this number, 450.268, and b is equal to 1.2567. So we have 450.268 divided by 1.12567 times e to the power of 3 times 1.12567 minus 1. So we're going to take 400 plus, and then we're going to go ahead and put this in our calculator and find out what this result is. So let's go ahead and first do what's inside the parentheses. So we have second e, and then we have 3 times 1.12567. And then we're going to subtract 1. And then we're going to multiply that by 450.268 divided by 1.12567. And we get 11,313. And we're going to round that to the nearest thousand. So that's plus 11,313. And so if we approximately add 400 to that, we end up getting 11,713 bacteria. And therefore, there's our result.